Welcome to HVAC Talk with Huff. I'm Huff. Today's video is an introduction to a series that we're going to be running. And the series is entitled, Your Filter May Be Wrecking Your HVAC System. Now, that may sound like a tough thing, and it is, but it's also, well, the truth. We have seen a lot of systems over the years where people have not taken in filtration into account, and they don't understand how filtration, the filters themselves, how they affect your duct design and your duct system and your airflow and your blower in your HVAC system, as well as the other subsequent parts that go along with that. I kind of came to this conclusion during the pandemic. When the pandemic hit, a lot of folks were concerned about wanting better filters. There was a question that started coming in. So when the pandemic hit, I was actually working for a major OEM. I was leading a tech support group in the Northeast. Occasionally, we would get a question that got passed to us that was actually a homeowner, but the majority of the people who were calling our tech support line were actually installers and service technicians and HVAC company owners. And the thing is that we kept getting the reoccurring question, and we kept getting it from both sides. It's one thing for a homeowner to call and ask the question. It's another thing for a service technician or an installer or a company owner to call and ask the same question. I know what you're thinking. What was that question? The question was this: what is the highest MERV rated filter I can install with your brand system? Homeowners would ask it. They had purchased equipment of that brand that we were supporting at the time, and they now want to know what's the highest MERV rated filter they could put in that system. And that makes, as a homeowner asking that question makes perfect sense. And the reason they were asking us is because honestly, most of them did not get the answer they were looking for from the contractor or from their service tech that was in their home. But to get that question from installers and service technicians was kind of alarming, because it really kind of opened up our understanding of the fact that a lot of people don't understand duct design, and they really didn't understand how altering the restriction in the airflow was, how it was going to affect the system. And, that made us realize that we had some work to do on educating folks. Now, let me say this. I think there are two classes that every installer, service technician, service manager, and HVAC business owner ought to take. Those two classes are this. First off, I think everybody should take an ACA Manual D course on duct design. Now, the thing is you can be in our industry and you can be a great service tech, a successful service tech for 40 years and never once design a duct system. You could be an installer for 40 years and never design a duct system, because that's typically done by, another function within our industry, another type of person. And so we just are out there working on, what someone else has designed. And that's all well and good until you're in the field and you're getting asked questions and you don't have the right answers, because you don't have a basis of understanding of how duct is designed and how filter changes can actually affect the duct system. So everybody should take an ACA Manual D course. Secondly, everybody should take an NCI Airflow and Diagnostics course. NCI stands for National Comfort Institute, and they have they have many courses that are absolutely great. But at the minimum, everybody should take their Airflow and Diagnostics course. Matter of fact, they have a little field guide that you get from that class, and I actually carry it in my backpack all the time. And those two classes would really help broaden everybody's understanding and help them make the right decisions and lead their customers into the right decisions for works, not only for their filtration desires, but also for the duct system and for the overall health of their entire HVAC system. In this series, we're actually going to be taking different types of filters. We're going to take the filter that actually comes in this air handler as it's shipped from the factory. We're going to start there, and then we're going to increase in MERV rating, right? So MERV is minimum efficiency reporting value. The higher the MERV rating, the better the filtration, right? The better it is at capturing those small particles. But also, the higher the MERV rating, then the higher of pressure drop we have across the filter. And you may be thinking, what is pressure drop? What is all that? Well, let me give you a brief explanation. Again, this is not a full comprehensive video. This is just getting down to the roots of it, if you will. And so Typically, your air handlers, whether it be this is a kind of a conventional type heat pump system. I got a heat pump with a standard type of air handler, has a coil, blower, and even a place to put electric resistance heat if I need that, depending on the load calculation and things like that. And this is kind of a standard type of air handler. Maybe you have a fossil fuel burning furnace like a gas or propane furnace or oil furnace. Whether it's a furnace or whether this type of air handler, they all have what we call a rated total external static pressure. Total external static pressure rating is the pressure that these things were tested at, and they say that's what the manufacturer recommends that you don't exceed. And so for this particular air handler, the total external static pressure rating is 0.5, right? 0.5, and it's 0.5 inches of water column. Now, again, you may be a homeowner like, what in the name of Jehoshaphat does that mean to me? Inches of water column, just so you know, and I'll put a picture in this video, they used what they call a U-tube manometer, and they would fill it up with water, and it literally had a ruler in it. And so they would slide that ruler until it read where the water level was, and that would be 0. And then as it read pressure, it would actually move that water, right? And so depending on whether, how far it moved that water, they would measure it in inches. And so a ½ inch means that pressure would move that water from 0 inches up to 1/2 inch. So that's 0.5 inches of water column. And so this is the measurement that we use to measure the static pressure that this blower experiences. Now, the measurement scale that we use isn't as important as understanding that we need to measure, right? And that this scale has been developed. And so the manufacturer says the total external static pressure of this air handler is 0.5. Now, what does that mean? Well, total external static pressure is the amount of pressure exerted against this blower when it's operating. So we have the pressure that it takes as the air is being moved through what we call our supply duct system, right? So supply duct is the ducts that supply the air to the rooms in your home. And so the amount of pressure that's exerted against the blower as it pushes that air through the supply duct, but then also the amount of pressure that's exerted against that blower as it draws through the return duct. And that return duct is the ducts that actually take the air and return it back to the system to be, again, conditioned, right? And so this blower experiences this static pressure both on the supply side and the return side, and we add those two pressure measurements together, and that's total external static pressure. Why is all this total external static pressure important? Well, because this air handler is rated for a certain amount of static, and so that's the starting place when we come to duct design. The very first step in duct design is we're going to look at the blower tables for this air handler. We're going to look at the total external static pressure rating for this, and we're going to, that's the start and the basis of our design. How much airflow do we need? How are we able to achieve that? What fan speed do I need to be on, or what CFM am I going to be programming this thing to actually be able to achieve for my system? And what is the static pressure rating for that, the total external static pressure that this air handler is going to experience? And so we start with that. But then the next step is we have to take account for everything that is going to be in the airstream, everything that's going to affect that static rating. And so when we start putting things in the airstream, such as filters, they have to be accounted for. Now, when we started really digging into this, we found that basically the default pressure drop across the filter that's used when a known filter, or we're designing and we don't know what filter they're going to use, the basic throwaway type of filters, the default pressure drop across the filter is 0.1, right? So that has to be deducted from our blower table to total external static pressure, right? That's our starting point. And then we have to subtract all of the pressure loss devices that are going to be in this airstream to find out what our corrected static pressure is going to be. And then the next step would be to then actually go to the longest supply run, the longest return inlet run, and figure out how long the duct system is going to be, not only in linear length, but what we call total equivalent length. That means we have to account for all the fittings, the transitions, the elbows that we may have to take to turn to go around things. All that has to be taken into account for. And so by the time we get to a full duct design, right, it's very detailed. And so if you can imagine that I've designed this total duct system based on this throwaway filter that comes in this air handler, and I have calculated that pressure drop across that filter at 0.1, what happens when I pull that filter out and then I put in a more restrictive filter? What do you think happens to the system? Now, what happens to the system is also predicated on the type of blower package, and that's going to be the next few videos. We're going to start covering that in a little more detail. But I want you to just kind of, if you would, set your mind to understanding that what we're trying to accomplish here is an education piece, so that we understand that not all filters are created equal, and that just taking out one kind of filter, just throwing in another, isn't necessarily going to achieve the results you're looking for. It may better filter the air, but what other issues could it cause? And we think about what kind of issues can it cause? Well, depending on the type of blower package, this has a blower that we call a constant CFM. And so what happens is when I put a higher restriction filter in this air handler, this blower is actually going to ramp up to try to still achieve that set airflow. Well, what do you think is going to happen to our power consumption when we do that? So it's important that we understand how this change in filtration affects our overall system. Now, if we have a different type of blower package, some of those blowers, instead of speeding up, are actually going to slow down. What do you think happens when the airflow slows down? Well, you're going to end up with less air volume. And how does that affect your system? Does it make it run longer? Right? Could it also damage things? Could it cause compressor damage because we are flooding the compressor? Can it cause heat exchanger damage on our gas furnaces because our gas furnace is overheating because we don't have the right air volume? And so it's important to understand that what may seem so simple as a filter can actually be a very complex issue, or at least cause very complex issues. And so it's important that we understand this. So we're going to be releasing videos over the next few weeks in which we're actually going to operate this system with different filter packages. We're going to show you a couple things. Let me explain what you're going to see. First off, we're going to actually show you in real time what the pressure drop across the different filter packages are, so you can see how restrictive it is. We're going to show you the total external static pressure of the system as it operates with these different filters. And then we actually have a wattage meter back here. We're actually going to look at our wattage consumption and find out how it affects the wattage consumption. Is it possible that I may go with a more restrictive filter and actually end up with a higher cost of operation? These are all important things. And these are things that homeowners are asking, and as technicians and installers, we should at least have a basis of understanding of how this works so that we can better educate our customers and make better decisions for them. Are there things that we can do? Yes, absolutely, there are things we do. Once we understand how this works, then if they want a better filtration system, absolutely, we can do that. We may have to make some duct modifications to achieve it, but let's do that. And people are willing to pay to be comfortable, and they're willing to pay to have a healthy environment in their home. Let's give them a healthy, happy home, and also make sure that we're protecting the longevity of the HVAC equipment itself. So look forward to seeing you back on the next video when we start actually changing out filters in this system. Talk to you soon.